Okay, good morning everyone. Today we'll look at properties of polynomial functions. Our objective today is to use properties of n behavior to analyze, describe, and graph polynomial functions and identify the domain and range. And then we'll identify any global and local maxima or minima of polynomial functions. Important things, particularly in higher level mathematics. So let's begin with a simple case, a simple linear function. What do we mean by n behavior? Okay, well, n behavior is what happens to the graph as x goes to positive infinity. So what happens to this graph as x goes to positive infinity? Well, as you notice here, as x increases, y is increasing. Okay, so we would say the n behavior as x goes to positive infinity here. Y looks like it's going to positive infinity. It's going up and up and up and up. As x goes to positive infinity, y goes to positive infinity. But now look here, as x gets more and more negative, what happens to the y value of that graph? As x gets to more and more negative, what happens to the y value? Well, as x goes to negative infinity, notice that the graph is also going to negative infinity. So y goes to negative infinity in behavior. Let's take a look at this graph here. What happens as x goes to positive infinity? Okay, as x goes to positive infinity. Notice that the y value for that graph is getting smaller and smaller and smaller. It's going to negative infinity. The y value is going to negative infinity. So the n behavior, as x goes to positive infinity, my y value is going to negative infinity. All right. As x increases, as x goes more and more to the right, y is getting less and less and less. In fact, it's negative here. At x is equal to 8, it's negative. And then what happens is x goes to negative infinity as x goes this way. Well, it looks like as x goes to negative infinity, the y values, they are increasing. They're increasing. They're going to positive infinity, right? They're going to positive infinity. So like at -2, I'm probably at something like 11 or so. So as x goes to negative infinity, y goes to positive infinity. So that's what we mean by n behavior. What happens to the graph as x goes, what happens to the y values as x goes to positive and negative infinity? Okay, so the n behavior is a description of the values of the function, the y values, the function as x approaches positive infinity or negative infinity. We will see that the degree and sign of the leading coefficient of a polynomial function determines this n behavior. It is helpful when you are graphing a polynomial function to know about the n behavior of the function. So what will be important is the degree of the polynomial, and the sign of the leading coefficient. And that will tell us everything we need to know about the n behavior of that polynomial function. So let's look at these cases. Here I have a degree 1. And the slope is positive. Okay, so as x goes to positive infinity, as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. All right. And then what about the quadratic function? Here. So notice as x goes to positive infinity, y is getting higher and higher. It's going to positive infinity. Y goes to positive infinity. As x goes to negative infinity, as x gets less and less, y too is still going to positive infinity. quadratic. What about degree 3 polynomial? Okay, so again, notice as x goes to positive infinity, y is going to positive infinity. So as x goes to positive infinity, y is going to positive infinity. And as x goes to negative infinity, the y values, they're going lower and lower. They're getting more and more negative. So as x goes to negative infinity, y goes to negative infinity. For the degree 4 polynomial, as x goes, as you see, as x goes to positive infinity, that graph is getting higher and higher. Y goes to positive infinity. As x gets more and more negative, the y values, the end behavior, it too is going to positive infinity. So as x goes to negative infinity, the y values are going to positive infinity. I want you to notice though, okay, for an odd degree polynomial, the end behaviors, they go in opposite direction. Degree 1, the y values are going up, the y values are going down. For degree 2 or even degree polynomials, the end values, they go in the same direction. They're both increasing. They're both going to positive infinity. For degree 3, again, the end values, they go in opposite direction. One is going to positive infinity, another one is going to negative infinity. For degree 4, even, the y values, the end values, in behavior, they're both increasing. They're going to positive infinity. And then for degree 5, the y values, the end behavior, they're going at opposite direction. One goes to positive infinity, one goes to negative infinity. So for even degree polynomials, the end behavior on both ends will go in the same direction. Even degree. Odd degree, the end behaviors, they go in opposite direction. So we have the polynomial end behavior. If I have an even degree, as x goes to negative infinity, notice with this one here, y is going to positive infinity. As x goes to negative infinity, the y values are increasing. As x goes to positive infinity, the y values are increasing. As x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. Remember, in chapter 5, we would say that that was a happy graph. The leading coefficient was positive, like x squared. But what happens if I have a sad graph, like negative x squared? Okay, I want you to notice there that as x goes to positive infinity, the y values are going to negative infinity. So as x goes to positive infinity, the y values are going to negative infinity. And then as x goes to negative infinity, the y values, they too also go to negative infinity. So as x goes to negative infinity, the y values go to negative infinity. Again, for even degree polynomials, the ends will go in the same direction. If the leading coefficient is positive though, okay, the y values, they'll go to positive infinity. It's a positive, it's a happy graph. If the leading coefficient is negative, for even degree, the y values will go to negative infinity. Even degree. The end behaviors, the ends for even degrees, they go in the same direction. They're going to the same place. Now for odd degree, as I've mentioned before, the ends, the end behavior, they go in opposite directions. If the leading coefficient is positive, so for example, f of x is equal to x cubed. Okay. As x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. Okay? If the leading coefficient is negative, though, for odd degree, like f of x is equal to negative x cubed, as x goes to positive infinity, y goes to negative infinity. The y values are getting smaller and smaller. As x goes to negative infinity, the y values go to positive infinity. Okay? So for odd degree, the end behavior, they go in opposite directions. If the leading coefficient is positive, we say it rises on the right and falls on the left. If the leading coefficient is negative, it falls on the right and rises on the left. So for example, if I have negative x to the fourth plus 6x cubed minus x plus 9, it's even degree. The ends are going to go in both directions. It has a negative leading coefficient. All you have to do is think negative x squared, which looks like that. And so as x goes to positive infinity, y will go to negative infinity. As x goes to negative infinity, y will go to negative infinity. It's even degree. The ends are going to go in the same direction. The leading coefficient is negative. The y values are going to get more and more negative. And there's a graph of that right there. Y is equal to negative x to the fourth plus 6x cubed minus x plus 9. Notice the ends are going in the same direction. But as x goes to positive infinity, y is going to negative infinity. As x goes this way, I know it's hard to see on the graph, but as x gets more and more positive, y gets more and more negative, and as x gets more and more negative, y too still gets more and more negative. The ends go in the same direction. And here's a degree 5 polynomial. Remember, the ends are going to go in opposite direction, but the leading coefficient is a positive 2. Okay, so I tell students, just always keep in mind, like x cubed is odd. And x cubed, it kind of looks like a snake. It always kind of looks like that. So it's odd degree, but the leading coefficient is positive. So that means as x goes to positive infinity, y is going to go to positive infinity. As x goes to positive infinity, y is going to go to positive infinity. As x goes to negative infinity, y is going to go to negative infinity. Rises on the right, falls on the left. And here's this graph right there. 2x to the fifth plus 6x to the fourth minus x plus 4. As x increases, as x goes to positive infinity, y goes to positive infinity. As x gets more and more negative, y gets more and more negative. End behavior. And so I just tell students, all you really need to remember is what happens, okay, with x squared when the leading coefficient is positive. It's a happy graph. When the leading coefficient is negative, it's a sad graph. And then x cubed. When the leading coefficient is positive, it rises on the right and falls on the left. When the leading coefficient is negative, it falls on the right and rises on the left. In behavior. Okay, so for example, that one there, notice that the ends are going in opposite direction. Has to be odd degree. Has to be odd. And the leading coefficient is negative. And how do I know that? Because it falls on the right and rises on the left. Odd degree. This one here, this 2, is odd degree. Odd degree. And again, the leading coefficient is negative. It falls on the right and rises on the left. Okay, if I had a graph like this here, it's even degree. The leading coefficient would be negative. Okay. If I had a graph like this here, It's odd degree. Falls on the left and rises on the right. It's a positive leading coefficient. Odd degree polynomials, in behavior, they go in opposite directions. And then the last thing we'll look at is global and local minimum and maximums. And then we'll also take a look at domain and range. Okay, so here I have a polynomial. It has factors, so I graph this y is equal to x plus 1 times x minus 1 times x minus 2. Okay, that's in factored form. It's a degree 3 polynomial because each of those factors have degree 1, x to the first, x plus 1, x to the first, x minus 1, x to the first, and x minus 2, x to the first. It's a degree 3 polynomial. The leading coefficient is positive. I don't have a sign out in front. It rises on the right and falls on the left. The domain, let's talk about domain and range. The domain of polynomial functions is always all real numbers. Okay, in other words, we can use any x to graph that polynomial. For odd degree, the range too is always all real numbers. Okay, the y values, they're going all the way to positive infinity. The y values there, they're going all the way to negative infinity. Okay. Now, what about global and local minimums or maximum? A global minimum or a maximum is the highest point on that graph. There's no point higher than or lower than a global minimum or maximum. There's no point that is higher on that graph or lower on that graph if it's a global minimum or maximum. So for this graph here, I don't have any global minimums or maximum because that graph just keeps going up and up and up. I don't have any. But I do have a local maximum, and that's right there. And I also have a local minimum. All right. Global is the highest point on the graph if we have a global maximum. If we have a global minimum, it's the lowest point on the graph. I don't have any. The graph is going all the way to infinity on the right and negative infinity on the left. That will always be the case for odd degree polynomials. Oh, and this is degree 3. Odd degree polynomials have no global minimums or maximums, none. Let's look at this one here. So notice, so I have x squared and then x minus 4. Now, my factor x squared is even. And all factors with even degree are tangent to the x-axis. You notice here, my 0 for x squared is 0, so I can see that it's tangent at 0 there. But my 0 for x minus 4, it has a degree of 1. My 0 would be 4, and I see it crosses the x-axis. So we say that factors with even degree, are tangent to the x-axis. They are tangent to the x-axis. Factors with odd degree, they cross the x-axis. They cross the x-axis, and that's very easy to see. Okay, if I have a function like f of x equals x cubed, if you take a number and raise it to an odd, if you take a positive and raise it to an odd power, you'll get a positive. But if you take a negative and raise it to an odd power, you'll get a negative. 1 times 1 times 1 is 1, but negative 1 times negative 1 times negative 1 is negative 1, which means that that graph is going to have to cross the x-axis as it goes from negative to positive. It's going to have to cross. But if I have like f of x is equal to x squared, the y value will never be negative. Okay, if I take a negative and square it, I'll get a positive. If I take a positive and square it, I'll get a positive. So we say factors with even degree, like x squared, are always tangent. They never cross the x-axis, but factors with odd degree will always cross. Across. And again, here the domain for that is always all real numbers. Very easy to remember with polynomials. And then the range, again, are all real numbers because that graph, the y values are going to positive infinity and negative infinity. Let's look at a couple more. Here I have x squared. So the factor x has an even degree, x squared, so it has to be tangent. What's my 0 for x squared is 0, so it has to be tangent at 0. That graph has to be tangent at 0, and it is. And then I have x minus 4 squared. Okay, x minus 4 squared. So that 2 has an even degree. So that 2 will be tangent at the 0 of 4. See, there's my 0 of 4. Again, factors with even degree will be tangent to the x-axis. Here, the domain for polynomial functions are always all real numbers. But now my range here, what's the lowest the y value get is about 0. So it's going to be y is greater than 0. Okay. Talk about, I don't have any global maximums though, because that graph just keeps going up and up and up. I do have a local maximum there. I have a local maximum there. But I do have a global minimum. You see, now I have a global minimum because there's no point on that graph that is lower than that point, those points. I have a global minimum. So even degrees will have global minimums or maximums. Even degrees. Odd degrees never have global minimums or maximums. Even degrees will. Even degree polynomial will. Let's take a look at another one. Here I have x minus 1 cubed. That factor x minus 1 is odd. It has to cross the x-axis at the 0 of x is equal to 1. And it does. And then I have the other factor, x plus 2. I have 4 of them. That degree is even. It has to be tangent at the 0 of negative 2. The degree of that polynomial, 3 plus 4, is equal to 7. It will have no global minimums or maximum. It's an odd degree. It's an odd degree polynomial. It will have no minimum or global minimums or maximums. But it does have a local max here. And it does have a local minimum there. But odd degree polynomials, they never have a global minimum or maximum. And again, the domain for that, always all real numbers, and then the range, all real numbers. And that's always the case for odd degree polynomials. Okay, so that's an overview. I know it seems like a lot, but it's pretty easy to understand. No mathematics involved in this other than just looking at graphs and interpreting what happens.